Hi guys, this is our third session of AXI protocol, and one of our students want to know that how to do wrapping calculation in AXI protocol. So we are making this video. So let's start the session. Wrap calculation. So before going to this calculation, first of all we need to understand a signal, as we discussed in our previous AXI sessions. The name is AW burst. So actually this is 2-bit signal and 00 stands for fixed type. That means like FIFO, it is nothing but first in first out. That means the address is same always, where user is going to write or read, right? After that, increment 01 is for increment type. That means like sequential memory. Means increment time is the example is sequential memory, where the address will be in increment format. Like let's say the first address is like address, after that address maybe +1, after that address +2, address +3, and so on. The address will be in incrementing format, right? And next one is 10 stand for wrapping. Okay, let's discuss about first is 11. So it is reserved. Means not in used, and this is 10 is for wrapping. So what is the mean of wrapping? The address will be wrapped out. So we will see the calculation how the address will be wrapped. Address will be wrapped between lower and upper boundary, right? So let's take an example. So let's see your EW size is 2. That means 4 bytes. And AW len is 3. That means 3 plus 1 is equal to 4 transfer, right? And after that AW burst is 2, that means 1 1, right? So that means wrapping type, and starting address is equal to, let's say, 0x104, let's say 4. So as we can see, the size is 4 byte and length is 4. So total number of transfer will be 16 byte, right? So there is some formula. What is upper boundary is equal to like integer part of or you can write like this one 0x1004 divide by 4 into 4, that means AW size into AW length, that is 4 into 4 and multiplied by 4 into 4. Okay, let's understanding another way. Write a generic formula. Starting address divided by AW size into AW len and multiplied by AW size into AW len, right? So means we will put our starting address over here and divide by this multiplication of AW size and AW len, and we will take only integer part of that, right? Just ignore the fractional part and multiplied by AW size into AW len, and we will get our upper boundary, right? Sorry, it is actually for lower boundary, right? So what will be the upper boundary? Simply upper boundary will be lower wrap boundary plus total number of transfer, right? What is total number of transfer? The same, the AW size into AW len, total 16, right? So these two formulas are sufficient. Now let's calculate the lower and upper boundary. So in such case, lower boundary will be integer of 0x1004, right, divided by 4 into 4 and multiplied by 4 into 4 simply. So now we need to use calculator. One 004. So in decimal this is this is in hex, right? And this is a decimal, and divide by 16. Oh, sorry. Okay. 1004. This is in hexadecimal, convert into decimal, and divide by 16. So it will come 256.25, right? And multiplied by 16. So as we can see here, this is int. That means we should ignore this fractional part 0.25, and we should take only 256, right? So 256 and multiplied by 16. That is 4096, right? (4096) in decimal, and in hex it will be 1000. So this is your lower boundary, right? So what will be your upper boundary? As we can see the formula over here, lower boundary plus total number of transfer. That means 0x 000 plus total number of transfer is 16. So it will come out approx, no exact, 0x 1010, right? So now the wrap calculation is complete over here. Now we can see the how address will be executed, in which order or in which increment order, right? So like the address will be increment like, first of all, our starting address. What is our starting address? This 0x1004, right? After that, what will be the next address? Plus 4, right? So next transfer will be 0x1008, right? The next will be 0x100C. You can see in the calculator our first starting address given by 1004, right? So 1004 plus 4, so 1008, as you can see over here, right? Plus 4, so 100C, as you can see, plus 4. So it will be 1010, right? 0x1010. But as you can see, this is our upper boundary 1010, as you can see over here, right? So the address increment will be in this sequence, like starting address, that is 1004, after that 1008, after that 100C, and after that it will not go to their upper boundary, right? It will just come back to the starting point over here, right? So it will come back to the lower boundary. So 0 x 1 0 0 0. It will not touch the upper boundary. So it will be the execution of order of address in wrapping calculation, right? So guys, this is the way that how we calculate the wrapping address, right? So guys, if you have any doubt, then please give a comment. Thank you.